back, everyone. We are on our second to last session of the day. We've been streaming for just over 8 hours straight now. The chat, the members, we're all still going strong out there. So we're in the home stretch. We have a ton of great stuff coming up. And with that, right now we're going to be talking about GitHub Actions to automate Terraform for Azure. This is going to be put on by Mr. Joe Houghes. He's a solution architect out of Austin, super active in the community as well. I believe he's one of the co-founders or co-leaders or, basically the boss, right, of the Austin PowerShell user group. I'm sure many of the people here on the stream today are very familiar with some of his work. So with Joe, with that, I'm just going to hand it right on over to you. And why don't you tell us a bit about GitHub Actions?
Sounds great. Howdy, y'all. So I'm Joe Houghes. We'll cover that a little bit more in the intro slide for myself, but we're here to cover GitHub Actions for automation of Terraform for Azure. I actually got this idea originally from a workflow that was printed up on Adam Bertram's blog by Michael Levan. And really the instance that made me decide to update this a little bit was I heard they were going to be making changes to a lot of stuff in GitHub Actions. So I wanted to take what he had in that blog post and actually make this essentially kind of an interactive walkthrough. So hopefully everybody has the opportunity to be able to pull down code and pull down all of the components that we're going to use here so we can actually run through this. So with that, let's go ahead and get started. So again, I'm Joe Houghes. I'm a solutions architect at Veeam. I've been a PowerShell user since Monad, but I'm still learning. I am currently a co-leader for both the Austin PowerShell and VMware user groups. I'm basically just a serial collector of communities. You can always find me by the green hat, the big green, and the loud howdy y'all. Obviously, as you can tell, I have little shame. Just some goofy pictures here from past conferences, and the one in the corner, which I've had quite a few people in the user groups locally tag as resting beach face. So there you go. And reason number 2 for me being here, got to throw it in, Kyle Reddy. I'm always here to troll this guy. So what we're talking about here, first of all, Azure, most of you guys already know it. We've already seen coverage for Azure in a lot of the presentations today. We've already even seen Terraform for Azure covered with Azure DevOps and a couple of pipelines. But, quick rundown on Terraform, right? This is just getting everybody into open source infrastructure as code, right? This tool is meant to just essentially manage all of your infrastructure through code. It's all built and using the HashiCorp configuration language, right? HCL. If you're just starting out with this, make sure that you're using V2, right? This is fully JSON compatible. Really all that means is it's supposed to be human readable and you should be able to just type this stuff out on the fly. Do yourself a favor though, get a parser. I recommend TF-Lint. I've actually got that in the resources for recommendations for getting started with this stuff. It's all built with declarative config files, right? This is all idempotent stuff where you can run these Terraform configs over and over and over again, and it shouldn't make any changes other than what is exactly necessary to get your defined end result. And it leverages providers for all of your resource dependencies, right? You don't have to write everything in the main Terraform module. The nice thing about this, with it being distributed the way that they're writing all of this code and all of these providers, essentially the Azure provider is managed by a team that's focused on Azure, right? So it's not the same folks that are doing Azure and all of the other cloud providers where they're missing things, right? It's a provider directly for Azure. It's got resource dependencies for all of the things within Azure, and it's all purpose-built for that. Getting into GitHub Actions, right? The whole point of this is just automating your code workflow. The great thing about it is it's CI/CD that you don't host, right? How many of us are tired of running internal, GitLab servers or running things on GitHub for checking in our code, but then having to try and run everything locally? If you're not running everything in the cloud, the wonderful thing about GitHub Actions as well is they actually have local runners. So you can have these GitHub Actions fire off, but go to runners inside of your environment. These are all triggered by events, right? Most of it, in fact, what I'm covering in here today is all really just pull requests and push. That's the only thing that triggers these events that we have going on inside of here. If you really want to get into it, these are actually extensible with your own actions, but you got to go learn some JavaScript. I have no interest in doing that, so I'm using everything that's online. And really, you're probably already using GitHub, right? So why not leverage additional functionality that's out there to just have all of your code perform all of its own deployments as well. So prerequisites for this, I know it's an eyesore. There's a bit.ly link up in the top right. This will take you to the GitHub repo that we're going to be working from today. Really, you're just going to need an Azure subscription. I'm running all of this in my personal pay-as-you-go subscription. It's going to cost you a couple bucks, but we're going to basically spin it up, tear it down. If you keep it up beyond that, the cost is on you. Please don't try and send me a bill. We're going to create a new Azure service principal to use for this demo. We're going to use a Terraform Cloud account. We're only going to be using this for remote state storage. We're going to be running all of our actions within GitHub Actions, keeping it all within GitHub. You have the ability to run this within Terraform Cloud and have all the runners run inside of the Terraform Cloud environment. We're using it here only for remote state storage, and this is free for that usage. And we're going to have this GitHub repository for the walkthrough, right? So you can take a clone of this repo. You'll have to create a service principal and then import in those credentials and this Terraform Cloud API token into the repository secrets, right? We're not managing everything, even with the secret TF vars file. We're actually leveraging GitHub repository secrets for all of these. As far as software, right, just Visual Studio Code is what I'm using in this. Azure AZ CLI installed. These are the specific versions updated on my slides as of a few minutes ago. I went and double checked everything. And then Terraform installed. This is just for a local test and for us to do the base init. So anyone who's not used Terraform before can see a small local run through of this before we run everything in GitHub Actions. Within GitHub Actions, all of this gets run on the runners. Those machines, amazingly enough, Microsoft has actually published, well, Microsoft and GitHub have published everything that exists on those runners, right? So if you want to know exactly what's installed on a box, if you're going to go use their Ubuntu latest runner, or if you're going to use the Windows runner, you can see everything that gets pre-configured and pre-installed on those boxes to know what's there. And then for code, we're just running with the local demo that's cloned to our computer. So let's go ahead and get rid of our slides and let's start bringing some stuff up. So to start with, I just want to show everybody, here's my, my Azure portal, right? The resource group that we're going to be working with here, oh, I want to say I titled Chicago PowerShell _ Full Stack Geek. That's just reference to my blog and make it easy for me to find and for me to also make sure that I didn't delete it accidentally while I was doing all of these demo creations and everything. Similar to Adam, I challenged myself to learn a lot with this, right? I'm still not terribly proficient with Git on the command line. All the stuff that I did today, I did additional extra run-throughs this morning to try and capture everything into a notepad so I can just try and copy and paste some of the demo stuff that I've got in here in case I run into a few issues or forgot to, fix formatting inside of one of my files and have to do, amends to commit messages and stuff like that. It's okay to be learning. Like Jeff Snover told us this morning, right? It's okay to make mistakes all the time. We will do it all the time. Just learn from them. And especially if you can, if it's not something, like terribly embarrassing or something that's going to be a resume generating event, share it with other people, right? Just help somebody else out along their journey. Either they're going to learn something based on your individual perspective, or you might save somebody else from making a really bad mistake that might have been perfectly fine for you, but might be a resume generating event for them. So all I'm doing here is showing within the resource groups, we essentially have nothing. To go ahead and start this off, for the first thing that we're going to look into, we're going to get into Terraform Cloud, right? This is just app.terraform.io. When I hit the main page, it's going to ask me to choose an organization. The one I'm using today is Chicago PowerShell, right? I should actually mention I totally goofed on this and forgot to show this to everyone. I do have inside of the demo code here a quick environmental prep. Let me open this in code so everybody can actually see it. If you have none of these components installed on your machine, right? I've got the script that you can just copy and paste here to install Chocolatey. If you're not using it, I recommend now is the time to leverage it quickly just to get all this stuff installed. And here's the lines you installed, VS Code, the PowerShell plugin for it, Azure CLI, Terraform, GitHub CLI, and TF-Lint. Not required, but I'm going to use at least the GitHub CLI in my demo, and TF-Lint is great just to have a linter for PowerShell. Oops. Yeah, I don't know why my PowerShell Pro Tools license thing is giving me errors today. Need to reload this box again. Okay. So sorry, back to the Terraform Cloud. So now that we are in our organization, what we're going to do here is create a workspace, right? I have this configured in my environment, but I'm going to walk everybody through what we actually have to do for this. So for this, we're going to create a new workspace, right? You're going to pick your version control provider. We're using GitHub here. I already have this linked to my version control, to my GitHub. If you are doing this for the first time, it will give you instructions to go set up authentication with GitHub to get into this. And then from there, you can actually see all of your repositories once you have this linked. And basically what this is doing is this is setting up your workspace to be a watcher for your repository. And it's going to make a difference as to what we're doing here. So I'm just going to go ahead and open up an old repo that I'm not using anymore and create a workspace, right? So we're just mapping this to the repository that we're using. In your instance, if you're following along with the demos, this is going to be the repo that you've cloned, which is this GitHub Actions -Terraform -Azure. So now we're just waiting for the configuration here. Sometimes it's easiest to just refresh. There we go. Okay. And the next thing we're going to do here with settings is just go to our general settings, and we're going to change our execution mode to local, right? This just means that the plans and applies are occurring on the machines that are running within GitHub as opposed to running within Terraform Cloud's infrastructure. So just hit save settings on this, okay? We now have our workspace created, and the last thing we're going to do is go under your user account. So under user, go to user settings, and then we're going to set up a token, right? So under here for tokens, you're just going to create an API token, give it a description, hit create API token, and now we can copy the token, right? Just click on the little button right here for copy and hit done. You're going to save this token, right? Open up a notepad and keep your token momentarily, because we're going to go set this into our GitHub repo. Not that I don't trust anyone, but I'm deleting my API keys because I don't want Kyle Reddy messing with me. And now that we have the API tokens created and we have our workspace here, the last thing you need to do, in case you didn't capture it before, is we're just going to want to know what is the name of our organization. In this instance, I'm using Chicago-PowerShell, and then the name of our workspace, right? And this is all inside of here. So once you have those values copied, we're going to go ahead and close out Terraform Cloud because that's all we need from it. So now that I'm in my main repository, let's go ahead and take a look at what we need to do to run some of this stuff here. So first, I'm going to go into code, and I'm going to clone down my repo. Of course, there's a new version of GitHub CLI. If Joe could type. Okay, so I've cloned down this repo, and I just put it into a folder that I'm titling local demo, right? And really all I'm trying to do inside of here is just take a look at the files that we've got, and it's a little bit easier in code rather than through the GitHub interface. So opening this folder inside of here, what we're going to start with is really 3 files that are in use at this point, right? We have our main TF file, our variables TF file, and our terraform.tf vars file. So in the main TF file, all I'm instantiating at the very beginning is our remote backend for Terraform. So this is just showing that I'm using my named organization and my named workspace, right? Because this is going to link up with the API key that we're going to put inside of our GitHub repo. Down here, I'm cheating, right? I'm using my prefix and environment variables that get used in a couple of different modules throughout here. And I just wanted to load them in. So I'm running a null resource to just essentially load those variables and output them as nothing. All we have in our main variables TF, right, is a prefix that we're going to put in, and then an environment that we're going to put in. And these are just values that I'm using to avoid naming conflicts, you know, in case you're running this inside of really populated Azure environments. So I'm giving mine a prefix of FSG, and I'm giving my environment a string of PowerShell Chicago demo. And that's all I have here in this main environment. Now, I've already connected with Terraform Cloud. If you have never run anything on Terraform Cloud, when you are in this environment and you try and run a Terraform init, it's going to tell you that you need to get the API key loaded in here, right? That it's going to be missing this. I already have this inside of my environment, and oh yeah, initializing a backend. Haha, you know what? Let me go. We're going to modify this one for our environment real quick. Let me go. Tell you what, this is only for demo, so let's go grab our workspace name. Doobie-doobie-doo. And go change my workspace name. And again, this is just a cloned version that I have of the repository that I'm using here just to show at least the Terraform init for a basis on this. And let's do, you know what, I'm going to cheat with this as well and do this easily. Sorry, this is naturally what happens when a demo goes sideways. Okay, I'm just deleting my .terraform directory just so that my init will start fresh, right? And again, since I already have my Terraform API token loaded inside of the appropriate file on my system, it will do the init, and basically it will just say, okay, I need to go grab the null provider because that's getting loaded in within our main.tf file for use, just to instantiate those two variables that I'm using here. So this will just show that we are connected to Terraform, and really all this is doing is validating that we are able to connect to our workspace up here. And now if I go back to my workspace and I go to states, we'll see that we have no states here. But if I use this, if I go ahead and stick with this new workshop, when I get into our production code, we'll see that we have state files that start getting loaded inside of here. So we'll just go ahead and make this demo a little bit more interesting, and let's do that. All right, so now that we have our Terraform init, just to make sure that our local system, if we're doing any of this stuff for troubleshooting or anything, can actually connect to Terraform Cloud and can put things into the remote state store, we're going to go ahead and get into the clone of our live repo. Okay. So now if I look at this, right, this is my local copy now of the repository that I'm using up here. And same thing, we've got our main TF file, our terraform.tf vars, and our variables TF file. So I'm going to go ahead and open up my main TF file with code so I can make the change to my new workspace name, because why not? Okay, so I'm going to change my workspace to a new name. And now what I'm going to go ahead and do here is close these out from my other open editor. We're just going to do a git status, right? And we can see I've modified only my main TF file compared to what's the live code that we've got up here. So for the rest of the setup for our GitHub repository, we're going to come over to settings. We're going to come over to secrets. And I've got a prerequisites markdown file inside of the repository for those that are following along, right? This prereqs will list out the names of these GitHub secrets as they are actually referred to inside of our workflow. So if you want to be able to just essentially copy paste everything and just, you know, let the actions run, you can just use these same names. I just preloaded all the secrets in here because I didn't want to spend time trying to, you know, create new stuff and load things up inside of here. But all the information that we need for this is covered with our walkthrough here. So we'll go ahead and set up the walkthrough, right, to get the other secrets that we're going to need. So with AZCLI, if you don't have AZCLI already authenticated, you're going to run AZ login. You're going to log in through your browser, right? If you've authenticated before, we can just do AZ account show. So let's go ahead and do this live. And we're going to get back just details about our Azure subscription, right? As long as this will, yay. Of course, this is the fun of live demos. Please don't judge me for all my open tabs. Okay, let me log into my Azure account. Already signed in, remain signed in with this account, of course. Okay. Sorry guys, I have problems with this autofill flipping back to my Hotmail account. Okay, let's look at the chat while we're running through here. Feel free to make comments and jokes. Really? This is fantastic. Account switching. Okay. Yeah, I see a couple people asking. Yes, all of this will be in YouTube, I think later on, or at least catch with like the video on demand for stream. Okay, let's go ahead and close this stuff out. There we go. Hey, now we're logged in and we have information about our account. So now if we run just again our AZ account show, we're gonna get this back. So I'm gonna go ahead and store this in a variable just because I don't wanna deal with the JSON, right? So this is just getting my account object and putting it into a variable. And now it's something a little bit easier to work with inside of PowerShell. So now the next line that we have down here is creating an Azure service principal, right? This is just going to define our name, our role, our scopes, and use the SDK auth parameters just to show that we're making this compatible with an SDK auth file. So we're creating a new one that's up here. I'm changing to a new Chicago PowerShell GHA Terraform name here. It's going to go ahead and automatically swap that to the valid URI that it's supposed to. So now if I took a look at my JSON object, we'll see that I've got, what I'm going to need out of this is client ID, client secret, subscription ID, and tenant ID. Keep those because you're going to insert those as secrets along with your Terraform Cloud API token. And if you want to just make it easy to get this information and put it out to your clipboard one at a time, so you can just flip from PowerShell to the GitHub page to go ahead and copy and paste these in, feel free, go ahead. Not that I don't trust anyone again, but I'm going to run my cleanup down here to purge that service principal. Oh, fantastic. What is... Oh, come on. Where object? Okay, you know what? Moving on. I'll clean that up on the back end in a few minutes. So now that we have our values, man, this is going fantastically. All we're going to do is go, again, create our secrets and put in our values. I've already got them in here properly using a different service principal. So go ahead and load those into your settings for the GitHub repo. And then we're actually ready to start taking a look at what's going on here. So inside of our code, right, I actually have essentially like step-by-step stuff that we're going to do here inside of TF file. So if you just go look real quick, I'm going ahead and creating all this stuff that's inside of here for, these are named improperly right now for RM, but these are actually our resource groups, our network, our VMs, and then a Kubernetes cluster that we're going through here. And the other code that exists inside of this repo is these workflow files. If you don't have any actions that are set up inside of your environment, when you click on this actions tab, it'll give you a button and say, do you want to create your own workflows, or do you want to look at some of these that are pre-populated? But since we have these loaded in here, these will go into this .github/workflows folder. And what we have inside of here are these YAML files. So for this workflow, I have one named Automated Terraform. Let me go ahead and zoom in to make this a little bit easier for everybody to read. And the triggers for this are on push, on the master branch, and on a pull request, right? And it has a single job inside of here running as Terraform. The name of the job is Automated Terraform Job, and it's going to run on Ubuntu latest. It's just, for me, that's usually easiest to run on the Ubuntu runners. Default shell that it's going to run is Bash. And then all the power in this is really in these steps, right? So within these steps, you can define things that actually have to run in a particular order, right? Within a step, I've got a step named checkout. This is just going to check out our code. We're using the new setup-terraform GitHub action as opposed to the old version that HashiCorp had out there. And this is where we're loading in our GitHub TF API token coming out of our GitHub repository secrets. And then simply all we're doing here for every step of this is we're going to run a Terraform init. I left some comments in here that, as long as you don't specify to not run the wrapper script from the Terraform setup, you can call out all of your output. So the standard out, standard error, exit codes, and all of that is available to you in further steps within your workflow once you've run this setup Terraform step. And then here we're doing a simple, Terraform format. We're doing Terraform validate. We're doing a Terraform plan. I've got a script that's in here, and this is a direct copy and paste from the examples from the GitHub Actions, or sorry, the Terraform GitHub Actions page. So this will basically just run, and if these pull requests come in on this repository, it'll run this script and it'll give me back the information about my initialization, my validation, my plan, and all this stuff will actually pop up in the pull request itself. And then we have apply set to run only on master and only if there's an actual push, right? And inside of these steps for plan and for apply, we're loading in our subscription, we're loading in our client ID, we're loading our client secret and our tenant ID, which are the other GitHub secrets that we have inside of here. So now that we've got all this stuff set up, let's go ahead and let's make some changes. So we're back to our main TF file where I just made a change for which workspace I'm using on Terraform Cloud to set all of this stuff to. So let me get my scripts up here for what we're going to run for our demo. So we're going to go ahead and check Git status. We've got our main TF. We're going to check out a new branch called pull output test. And I'm moving all of my items that are in that TF files directory that are under one, right? This is essentially me creating just my resource group. So before we get into this, let's go ahead and take a look at these files just so y'all can see the very basics of what we're doing here. So inside of code, we're going to just call in our subscription ID, our client ID, client secret, tenant ID, and then we're specifying a location. That is the only thing we're actually specifying inside of our variables for this point. So if you want to run this code inside of a different location than South Central under Azure locations, then feel free. All you need to do is change that here. And then this provider is just calling in our subscription, client IDs, secrets, tenant IDs. There's a blank bit of stuff here for features because this is required by the Azure RM provider, but I'm not using any of this stuff. If you're doing Key Vault, if you're doing virtual machine blocks for scale sets and stuff like that, you can fill this out here, but since it's required, I've got this in as just an empty block with some comments. And again, for the resource, all I'm doing is defining the name for the resource group, the location that's coming in from our TFR file, and then I'm putting in my environment. And in this instance, I'm just manually tagging it as PowerShell Chicago to show that you can actually override these here locally, different than what you have in your variable files. So now that we have all this stuff loaded in here, I have these files moved out of that subfolder into my main directory. I'm going to add them in Git. We're going to do one quick Git status again, and we should see that we have all of our one.bat files moved out of our subdirectory. They're in our main directory, and we have modified our main.tf file. So let's go ahead and do a commit and a push. And now at this point, we're just going to go back and we're going to start watching things inside of GitHub Actions. So our push has completed successfully. So if we go look at our actions, it's going to take a second here for this to load up. So while we're waiting, I will go to Automated Terraform. Oh, I'm sorry. I forgot what I was doing here with this demo. Yeah, for this one, sorry, since we're doing a pull request, we actually need to compare and do a pull request from the main page up here. So my bad. Yes, testing our pull request. Let's go ahead and create a pull request for this code that was submitted in and see what happens. And now it starts running through our plan. So at first, we're just going to see no conflicts on the base branch. It takes a couple of seconds for GitHub Actions to catch this and then start running. So now if we click on details here, we can actually see it's our automated Terraform job and then automated Terraform workflow and then named automated Terraform job that's actually running here. So when we look at details, we can see what's actually going on here, right? It sets up the job. It ran our checkout step. It's doing the Terraform setup. We're running through the init stage right now. As long as everything works here, we should be good. Oh, come on, don't fail on me now. Ooh, live demos. Okay, you know what? I'm going to go ahead and go into my settings. There's a chance that I deleted the Terraform API key or API token that I was using earlier. So let's go set this up real quick. All right, now we will go back to my actions. We will see, yep, this failed. And it failed, it looks like on our init step. So, nope, Terraform init succeeded. It just took forever. So what actually failed here is something that I had inside of the demo that was set up to fail inside of one of these TF files, right? And this is just because I'm using the Terraform FMT command to do the formatting into canonical format. And I'm running it with these check and diff parameters. So that way the output that's in here, I can actually see what I have goofed up inside of this. And really this just tells me that within this file, this az1 underscore rm underscore auto.tf vars, I've got a couple of extra spaces inside of here. So what we're going to do is go ahead and open this up in code. And it's not liking that I have more than a single space here inside of this gap between location and the equal sign. So we're just going to go ahead and save this again. And now what I'm going to do here is we're going to say, I have goofed this file. I'm going to add it back to Git. I'm going to do a git commit amend. And we're going to say Kyle Ruddy would have done this correctly and maybe would be able to spell. Okay, so we've now made an amend on this. So let's go ahead and do a git pull. This is some of the stuff where it gets a little bit gnarly, right? I'm going to set my branch to the upstream for this, do another git pull, and then git push back to the origin. And hopefully we'll get back on track here. So if I go back to my pull requests at this point, if this will load, we should see that I've made my new amends to this, right? And now we're going to see it start loading through the workflow again. So while that's running in the background, let's go ahead and pull up details and let's see what happens. Okay, we're running through our checkup again. Move my Azure to the other side. Okay, we have made it through the format. We have made it through the validate to show that we have a valid configuration. We've made it through the plan, which just shows us that we're going through here. And at this point, we're going to set up a new resource group, right? I'm calling it demo RG. Name is PowerShell Chicago underscore full stack geek. Environment is PowerShell Chicago. The plan has completed. And yep. Okay, everything is good. If we go back to our pull request, we will see inside of here that all of our tests should have passed, right? The bot will give us information. It'll show us our full plan that we can extend out here. So from the pull request, you get back all the information that ran through that workflow. So now if I say, I want to go ahead and merge this pull request, let's make a comment of, finally got it right. Confirm our merge. We will merge in. And at this point, we can, you know what, we'll just leave the branch for now. I have no reason to deal with this. That's just going to take longer to run things in the background. Okay, so now we have completed a push back to master. So it's going to be running the plan again, and this time it's not going to skip our apply state, right? So we're running through the init, we're running through the format, we're running through the plan, and we're just waiting for this thing to happen. So we're waiting for the apply. Okay. All right, so apply is done. Sorry, getting back to here. So now if we go back to resource groups and take a look again, we have a new resource group, right? No resources in it, but the resource group is here. It exists. We have now created this PowerShell Chicago _ full stack geek. So at this point, we're going to go back and take a look at our code again. And I'm going to switch back to code. Let's switch back to our master branch. Let's do a Git Pull to get this back up. Okay. If you want to do all these commits and everything, and if you want to handle the merges at the command line, that's all perfectly fine. I just do it in the UI because there's a lot more people that are used to the GitHub interface than are used to dealing with everything at CLI, like myself. So what we're doing inside of here, oops. What did I do? Oh, yes. I'm sorry. I missed. I had a bad carriage return in here. What we're doing next is we're creating another branch for Add Azure Network, right? So we're calling it Add Azure Network -2. We're taking the 2.0 files that are inside of this directory, which are just the vars and specifications for our network itself, which we'll open up. So we're defining an address space and an address prefix, right? That's all we're doing inside of here. We're going to create this resource. We're going to pull in those variables that we originally have for our existing resource group for the name and the location, and we're going to define an address space for the VNet. For the subnet, same exact thing, right? What's our environment name? What's our network name? What's our resource group name? And then here's the address prefix we want to use for it. And then for creating a public IP address, the only thing I'm defining inside of here is what's the allocation method that I'm using for this. And then to modify this for something different for your environment, if you go into this just aznetwork.auto.tf vars file, then you can define your address space and your prefix, and this will all be ready to go. So now if I do my push on the proper branch, we will see this push happen. And again, we now see we've had a branch that's had yet another pull request come in. So this time, this should be a clean pull request. So we're going to create the pull request where everything should work properly on this run through of the workflow for Terraform. So we're waiting for this to start. We're going to go ahead and let it start going in the background. And let's take a look at the chat while we're in here. Oh my goodness, I see KM Ruddy actually set up a Twitch account to chat. He must have wanted to troll me so bad. I feel special. Okay, y'all, hopefully everybody's understanding that, obviously, yes, like demos happen badly, go a little bit weird. But yeah, we're getting through this real quickly. Okay, the poll is good. All the planning came through just fine. So again, this is just demonstrating if somebody were to go define their custom network that they wanted to add inside of this thing and you want to let them control that and put in their options, we can just go through, again, do merge request. Everything looks good with here. I'm just going to go ahead and do an auto. Now we're going to go back and watch our action again. We should see the apply. So under all workflows, right, we're watching this automated Terraform workflow is the one that we're actually running here. If I want to see only the runs of this particular workflow, I can come and just click on automated Terraform. The list has not changed because I have yet to run this manual destroy. But in this run of the workflow with our merge, we're again just going to watch it. Going to see our Terraform init, the format, the validate run quickly. The plan should show us that we are going to be refreshing our state. We're going to create a VNet. We're going to create a subnet, and we're going to create our public IPs, right? All that stuff's going to be here. And then the apply is going to run. This one should run pretty quickly. Okay, our apply is done. So let's just go back to our repo, and now let's refresh our resource group. this may be a little bit dark. Close your eyes, everybody. This might be blinding. Okay. Hopefully this shows up a little bit better here. Azure's taking a while to refresh. Let's go back to my resource group. Okay, there we go. Now things are showing up. So we've got our VNet, we've got our address space underneath that. We have our public IP address, right? This is everything that we've defined at this point that we want to have inside of here. So now what we're going to do is create some VMs. So I'm going to do this one, and we're basically going to go with the F it, we're doing it live method. So for the VMs itself, we're going to create an availability set. We're creating a definition for NICs. We're creating virtual machines. And then, you know, all the information for the disks, the source image reference that are inside of here. The variables that are actually getting specified to all of this code are just the VM size, and then around the image itself, right? What's the publisher, what's the offer, what's the SKU, what's the version, and then a username and password for admin. So we're just defining here, right, a VM size, an image publisher. We're going to do server 2016 data center, latest version. I'm creating a local admin and a local admin password for this thing, and that's it. So inside of here, let's go ahead and get this deployed. And like I said, we are going to go with the doing it live method. We're going to switch back to our master branch, do a git status, and everything looks clean. I'm going to move these files out of this subdirectory here. And let me go add them to Git. Let's run a straight commit for this. We're going to go with feeling lucky, let's just push it. All right, push this back to our master branch. Oops, forgot my Git Pull first. Haha. Okay, so now if we go back into our actions, we're gonna see that the merge is already coming in from this. We've got a queued up job. This time it's not going to stop with doing just the plan. It's going to run all the way through the apply state because we have a push on our master branch. So it's just going to make it happen, and it's going to start deploying virtual machines. So we're going to let this run. This one's going to take a little while in the background just because the VMs take a few minutes to actually get spun up. And this is probably a good time to go start taking a look at the chat for this. Yeah, sorry, Arturo. I tried to warn everybody before I flipped to bright white. So if anybody's got questions, this is running for a few minutes and we can take a look at it real quick. If not, as soon as this is done, I'm going to go ahead and push for our last step, which is our Kate stuff. I'm going to go ahead and get that set up. Again, all I'm doing in this, I'll pull up the files quickly in just a second to actually take a look at them and show you all what we're doing, but I'm going to just go ahead and prep my push. So what I'm doing here is I'm using these last 4 files, right? So we're going to take a look at these again for our Kubernetes cluster. So for these resources, right, we're going to create a log analytics workspace. We need a name suffix, right? So we're giving it this weird byte length because we have to have this workspace name be unique across all of Azure, not just like currently running stuff inside of our resource group or region or anything. We're defining what we need for this log analytics solution. We're defining our Kubernetes cluster with just a name, a location, resource group name that we're shoving it inside of, and then like a DNS prefix, right? What's the Linux profile stuff we're going to put in here? I'm loading in Ubuntu for the local username. I'm actually piping in what I have in the root here, which is a public SSH key, which you can load into your repo. You can do these in code. You can do them in secrets. You can handle these, you know, tons of different ways. And then for the Kubernetes cluster, we also have to define like the node pool, which service principal is going to be used for this thing, and then our add-in profile, and then our environment. This time I'm bringing in the tag from our variable file rather than hard coding this. And all the stuff that you need to specify here is going to be just the workspace name, the SKU, a DNS prefix, a node count for our Kubernetes cluster, the public key, the name for the cluster, and the name for the Linux admin, right? And these are all just defined here. At this point, I'm actually using the per gig 2018. You should be able to use the free Log Analytics Workplace SKU, but you would have to double check that. I did not test it just because I forgot to change that one to the free tier. But let's go back and check. So our apply is still creating on virtual machines, but let's go ahead and take a look inside of Azure and see what is going on here. So we have at least finished up, right? We've got our virtual network. We've got the public IP address that we set earlier. Our NIC definition has come in. Our availability set exists. The virtual machine is being built right now with a disk attached to it. It's just still taking a little bit for that apply to actually run. I want to say this was around 3 minutes and 11 seconds, 3 minutes and 20 seconds. The last couple times I have run it. Yes, Lee, that is quite a few VS Code extensions in here. I run a few too many. I probably need to go through and trim some, but I'm a chronic tester of things that I don't understand.
Hey, Joe, we are a little light on questions from chat at the
Sure.
moment. I think we had a question or two from earlier. I do know it looks like we're going a little bit over, so maybe we could do like an ad hoc Q&A right now, and then we could jump back into the demo and close
Sure.
out.
Yeah, so I can skip the step to do the actual apply for the Kubernetes cluster, and we can run through just the last workflow, which is just the manual destroy, and that'll wrap us up.
Okay.
And that can run in the background. I just want to show everybody the code and show everybody how to push a button basically to run a workflow manually.
Okay. Yeah, I think that works just so that we make sure we stick with time for our next speaker. So
yeah, sorry, it's running a little slower than it should have.
Yeah, that will happen.
It's running on Texas speed.
Oh, come on now. Still creating. Kyle, I'm going to put in a feature request that you have this run faster. You got to have something you can do about this. And for folks that don't know, I'm not trying to be mean here. I'm just I'm pretty good buddies with with Kyle, Mr. Make It So there in the chat.
You had his picture on your slide.
Oh yeah.
We know your frenemies.
Buddies. Har har. Okay. All right. So this apply is still running here. Sorry, y'all. Everything is running a little bit slow. So what I really want to show is within the actions, under this action that I have that is this manual Terraform destroy, right? This is a new feature that they added to GitHub Actions where you can actually run a workflow manually, right? So you can just click on this workflow button. Right now I have it actually still set up to pick which version of the workflow you want to use from the branch, like from master or not, but you can just hit run workflow. And that comes in because of the fact that we actually have a run status in here for on that is just on workflow dispatch, right? By having this on workflow dispatch, this essentially says, just give me a button that I can push for this. The version that I copied in also has the ability where you can put in like a specific log level that will get passed back inside of here, and a default you can set for it. You can also set a tag through this and have it just give you a description so somebody can freeform in a tag. All those variables will come back in and you can use them further down inside of your workflow. And in this instance, all I'm doing is I'm doing our same checkout. We're doing the setup for Terraform to basically just say like connect with the Terraform Cloud to go pull in our state file, run the init, run the validate to make sure that our configs are still good, and then just run a destroy with auto approve. And we're pulling in again our subscription client IDs, secrets, all of that stuff. And for the last thing to show everybody, I will just go ahead and come back in to take a look at our workspace that we've been using up here, where I just renamed this dummy one. And you'll see that every time we're triggering these workflows from GitHub Actions, the states for these are actually getting stashed here inside of Terraform Cloud. The nice thing about this, especially with the things for Kubernetes, you can put in output for everything and basically have all of your kubectl config get stuffed into your state file. And you can control all of this and keep it separate from your open source GitHub repos. And honestly, that's the end of it. All we're really doing is waiting for the action to finish with the run. And I can at least just show everybody the manual destroy, just to say we can push a button and watch it delete everything. And if anybody's running this on their own, if you want to go run through the Kubernetes deployment, that takes maybe another 5 minutes or so for it to run through all of that. But I've clicked the button for run workflow. Now, if I go back inside of all my workflows, we will see that we're doing a manual destroy. And at this point, you can just sit here and watch this. It'll run your init, it'll run your validate pretty quickly, and then it'll just start running through the plan to. Oh, my init did not like my token. Urgh. Oh, yep, same token that I deleted earlier. So there we go. I will go fix it. But at this point, let me go ahead and stop my screen share. That's all I've got. Some broken demos to fix.
Yeah, it seems like the stream gods have been working fairly well today, but some of the demo gods are a little mad. They must have traded off today. I have one question for you.
Sure.
We are a bit over, but I wanted to get this out, so maybe we'll just run through this real quick. So I know GitHub Actions, right? It's kind of like, I think for a lot of the audience here, kind of like the new kid on the block.
Yep.
Especially a lot of the use cases were more specific, but now that they're adding things like manually being able to run builds, and there's a lot of stuff happening there. Kind of like I asked David in the last session, like where do you have any thoughts on where you draw the line between using something like, in this case, we'll say Azure DevOps, which I'm sure the community on the stream today is very familiar with, and Azure GitHub Actions. There's more choices out there. Like why should I look at GitHub Actions specifically? Is there like a line that I should draw when I want to use one or the other? Any kind of thoughts on that?
There's not really a hard line to draw on it. GitHub Actions leverages the same backend as Azure DevOps. Just my personal opinion, there's a good chance that they're going to decide in the future only one of these is going to stay alive. So learn both. Be prepared to make a switch if that's something you need to be ready to do. In the end, I would say at least get proficient with GitHub Actions for things like, if you're managing code, even if it's just your own internal infrastructure resources, use some of the GitHub Actions that will clean up titles for pull requests, that'll properly tag things and stuff like that. You can have runners that go in the background that just manage your GitHub infrastructure, and that's it. But you at least learn how they work. You can see how the workflows happen. And for some people, GitHub Actions and some of the simple examples that are out there may be a little bit easier to learn. If you're still trying to understand the methodology of workflows, that may be easier than Azure DevOps. It's really just up to you. I would say there's no cost to it. So if you're just wanting to learn GitHub Actions, go set up a demo repository and just go run actions against your own comments and stuff.
All right. Yeah, that's awesome. Great advice. So I think what we're going to do is we're going to hard cut to the ads. I think this, as a penultimate session of the day, I think that was great. But we're going to talk to our sponsors here for a bit, and we'll be right back with our final session of the day. So don't go anywhere, folks. Thanks again, Joe.
Hey, thanks, Joe.
Thanks.
Absolutely. Thanks, Joe.